Hello everyone. So let's start solving today's daily Leetcode challenge question. So the question is kth largest element in a stream. So we have to design a class to find the largest element in a stream. Note that it is the kth largest element in the sorted order. Okay, not the kth distinct element. So the kth largest class is which has this constructor which will initialize the object with integer k and stream of integer num, and we have this method where we will add this value to to our it may be array, it may be linked list. We have to select the data structure. Okay, we have to append this value in a stream, and we have to return the element representing kth largest element in a stream. So if we see the example, initially kth largest, this is basically calling the constructor. Okay, that means creating an object. So here key is 3 and this is our nums array. Okay, so here if we call this add method, there we have to insert this 3 into this array and return the kth largest element. So k is 3. So what do you mean by kth largest is this is the first largest. 8 in this array, 8 is the first largest, 5 is the second largest, 4 is the third largest. So we have to uh, count k from higher number or larger number. Okay, not from 2, 4, 5, 8. Okay, so here 4 is the output for this second add. Okay, next add, we have to add 5. So if we add here 5, then first largest will be 8. Second also here already 5 exists, so second largest is 5. Again we are adding 5, so third largest will be also 5. Okay, so that is why it is returning 5. Here what is given is kth largest element in the sorted order, not the kth distinct element. Okay, because 5 can occur twice, so we have to count both also. Okay, so this, if we see here this, so if it add 10, then 10 will be our first largest, 8 will be our second largest, 5 will be our third largest. So we have to stop because k is given 3, so we have to return 5. So if we had 9 also, then 10 is the first largest, 9 is the second largest, 8 is the third. So every time we have to add, and then that number will be considered for the for next time also. Okay, so if I am adding 10 before 9, that means it is already in array while while checking for 9 element, means after inserting 9. Okay, so this is first largest, second largest, third largest, so it is the output. So if we add 4, then first largest is 10, second is 9, and third is 8. Okay, so we are returning 8. So here you can see this is our output. Here what we have to do is kth largest we have to return. So how we can approach this question is, first brute force will be what we will take an array or linked list. We will sort the array by descending order. Okay, and at kth index we will return that, but we have to solve it using, like, we have to solve optimizely, right? So that is why what we have to do is, you can see we want only three elements in an array which are largest. Okay, so here 2 doesn't matter because 8, 5, 4, these are three largest element in this array. So if 2 is there or not there doesn't matter. Okay, so if we are adding 3, so we can see here uh, 4. Okay, so if we, let's say if we remove 2 from our array because we don't need it, so we have our array size of 3 which has all the 3 as a largest element. Okay, so because the k is 3, if the k was 4, we can keep all this 4. Okay, so if we add 3 in this array, what we will check here, what is our third largest element? 4. So if we add 3 into this array, is there any change with the kth largest element, or is there any effect? No, right, because 3 is less than 4. So if we add 3 also, then also our answer will be 4. Doesn't like matter anything. So if we add 5 here, if we add 5, our answer is changing, right? Because 5 is the third largest element. So we can remove our 4 because now we have inserted 5, so we have all top 3 largest element. I'm talking about top 3 because the k is 3. Okay, then if we add 10, okay, if we add 10, then 10 is greater than our third largest element. So we can add it, then we can remove that third largest element and we can have only 10, 8, 5 in our array, right? So similarly, for 9, 9 is greater than our 5. Then we can remove this 5 and we can have our array as 10, 9, 8, because 8 will be answer. It will be easy for us, right, to keep track of kth largest element. So if we add 4, okay, it doesn't matter because our kth largest element is 8. If we add 4 in an array, so there's no change in our answer, or there's no effect. So we'll not add. So we can make use of heap, okay, min heap. So we can have only here k sized min heap, okay. So we will add a element when this method is called. We will add this value when our uh, peak element, that is the largest third largest element, because we are going to insert only three element, okay. Third largest element is, if it is less than our current value, then only we will add it. Or we can say like this ki, if our array size is less than k, okay, because we want k elements at least, because kth largest will be first smallest element in k elements, k sized array, okay. So if if the array, okay, if our min heap size is less than the k, then we will add without checking. And if the value, okay, if the value is greater than the top value, okay, if the value this, if 10 is greater than 4, right, 5 here after inserting, then we will add this 10 and we will remove the top element. Okay, so we can make use of min heap. To implement min heap, we use the priority queue. Okay, so let's start coding. Here we want this k, then priority queue. It's like integer pq is equal to. So okay, this is just a declaration. Now here, this is a constructor. So this dot k is equal to k. Now pq is equal to new priority queue. Okay, where the size initial capacity will consider it as a k. Now let's traverse this and num. Okay, num. Now we will check if two conditions, right? So here we don't have to add all this number. We can add only top three which are largest. Okay. So for that we will check if our pq dot size is less than k. That means if the size is less than k, then definitely we have to add because we want a kth largest, right? So pq dot offer will add our num. Now if if our number, if it is greater than, okay, if it is greater than what, uh, so pq dot peak top element, okay, if it is greater than top element, then we will insert it. And again we will check, again what we will check, if pq dot size is greater than k, then we will what, that means we are removing the top element. So in this case we can see, for for this element, okay, our size, priority key size is 0 initially. This is what, this is capacity, not the size, okay. So initially it is 0, so it is less than k, less than 3, then we are inserting this num, that is we are inserting this 4 in our priority queue. Then in the next iteration 5, so 5 we will insert because it is less than k, uh, I mean size. Then 8 we will insert. Now we got our three elements because the size is 3. Then else if is 2 greater than pq dot peak, peak means we will get 4, okay, because we are implementing mini. So we'll get 4. If 4 is 2 is greater than 4, no, so we will not include this 2. So now our array is this. Okay, so let's say here instead of 2 we have 10. Okay, so in that case 10 is greater than 4, yes. So we will insert that 10 in our priority queue, and we will check if our priority queue size is greater than k, yes, because we have inserted 4 elements and the k is 3. Then we will remove the top element pq dot poll, so the top element is 4. So we'll remove it, and we have 5, 8, and 10. Our three largest element, top three. Okay. Similarly, we have to do this in add. Here, same conditions we will use. Okay. So here we will be using if pq dot size is less than k, then we will add that element. Here instead of num, we want, okay, here want what we want, val. So we will insert val. If our value is greater than pq dot peak, then we will add that value and we will remove the top element, and we have to return the pq dot peak because that will be our largest, third largest or kth largest element. Okay. So what we have done, we have our class as kth largest, and this we have to declare. You can use the private also. Okay, is access. So priority queue, then here this dot k is equal to q, and we have initial, because here it is written right in the kth largest, this is like a constructor. So here we have to initialize our this k and priority queue. Okay, so whatever object is, so we are using priority queue. So in nums, our nums array, then if pq dot size is less than k, then we have to insert that element. Okay, and if else, if our number, this number, if it is greater than the top pq dot peak, okay, then we will insert that number, and we'll check if our priority queue size is greater than k, then we will poll. Okay, we'll remove the top element, and top element will be the smallest element in min heap. Okay, so in add we have value, so we are checking again if our priority queue size is less than k, then we don't have to check anything, we have to just insert it. Okay, so we are inserting our value. Else if our value is greater than the top element, then we will insert the value, and we have to remove the top element. Okay, and also we have to return the top element because that will be the kth the largest element, as this is a mini. Let's run. Okay, you can say accepted, submit the code. Yeah, our solution got accepted. So thank you so much for watching this video. If you feel this video is helpful to you, then please like this video and subscribe my channel. Stay updated.